Okay, welcome to the satellite communication course. Today we start here what are the orbital parameters of a satellite. So we have seen that in the Earth we say that it is about a spherical shape. Okay, Earth is of a spherical shape. Now consider that we can say that this one is about your equatorial plane. Okay, this is about your equator. Okay, that is about we can say it is about you can say equator. Okay, so now we can consider that we have the satellite orbit, or we can say that a satellite path. Now consider that this is about your satellite orbit. We can say that a satellite orbit. Now I am saying that a satellite is rotating. Here we say this is the north point and this one is the south. Now the satellite is rotating from south to north. Okay, satellite is rotating from that that orbit. It is rotating from the south to north. So when it is rotating from the south to north, so now at the point here, there is a point. This is nothing but a point here. That intersection of this equator and here the intersection of the equator. From the south to north point where the satellite orbit crosses that equator. So now this particular point we say a ascending node. This is called as a ascending node. And this particular point is called as a descending node. This is called as a descending node. Ascending node means what? That is from the south to north. And this is from what? A north to south. Okay. This is from the south to north and this is from the north to south there. So now this is about a node, and these nodes, these two particular nodes are there. That nodes joining a line. Okay. Now these are the nodes. These nodes are joining the line. You know, suppose I am connecting this line here, and this one is called as a line of nodes. This is called as a line of node. Okay, this one is called as a line of node. Now, yesterday we say that the angle of inclination. Okay, likewise we say that this is about nothing but a line of nodes. That line joining the this ascending node and a descending node. Okay, that's called as a ascending node. That is about a line of node. Now, from this particular line of nodes, okay, now this is about a line of node now, and this is nothing but you can say a ascending node now. Okay, this one is nothing but a ascending node. And from this, suppose we say that a point on this orbit which is a nearer to this. Okay, so point in the given orbit. So again, I am just going to redraw here. This is about our Earth. This is nothing but we can say it is about a orbit now. And this point is nothing but we can say, sorry, this one is about you can say it is a nearer suppose. We consider that. So perigee. And this is about a apogee. Now that point from this perigee where we have that equatorial, this one is supposed to be line of nodes is there. This one is a line of node. Now from this line joining this that point of perigee, that's from the center of the earth to the perigee point, and this line of node, and that is called as a angle of perigee. That is called as the angle of perigee. Okay. So angle of perigee means what? This one is a line of nodes. This one is a line of nodes, and from this line of nodes to the a line joining from the center of the earth to this perigee point, that is called as the angle of perigee. We just termed it at omega here, and then at some particular point where I am saying that a vernal equinox or some particular point, and that is point is to be considered as a reference. This point is to be considered as a reference. Now, if you see that line joining from this reference point, that reference point is called as a vernal equinox. From this point to the what you can say line of nodes, okay, to this particular line of nodes, and this angle we say we can call it as a right of that we can say it is of a right ascension. Okay, that point, that angle is called as a right ascension angle, and that is to be termed as a omega. Now then, one more point that we have seen, that is the inclined orbit. What is the angle of inclination? Suppose again I redraw the Earth. Okay, now this is about your Earth now. Okay, this one is about Earth, and this one we can say that equator. This one is about your equator, and now this is about, we can say, we have the orbit, that is about your satellite. Now from this particular point, so we can say that we will see that this is nothing but a reference point, and this is nothing but, you can say, an angle of inclination with the given orbit. So according to that, from this plane of this particular orbit, we can find out the angle of a inclination. These are about the parameters we have learned in the last lecture. Now we have mentioned that whatever the terms that is about, you can say that angle of inclination between what, the equatorial plane and the orbital plane. We can say that this one is about your equatorial plane, and this one is about your orbital plane. That is about a reference plane we have. Orbital plane is a reference we consider. So now from that we can find out that inclination angle. Next we study here. Okay, now we study here a solar time and a sidereal time. Now, what do you mean by the solar time? So generally we consider that the period of a satellite, that is to be considered in terms of particular time there. Okay, that what you can say that a satellite, or you can say that a period of a satellite, okay, that we can consider that period of a satellite, we need to be considered with some particular reference time. Okay, for getting this period of a satellite, we need to consider some particular reference time. But in the case of, in our daily system, okay, and our, or you can say that our calendar, it is showing that how your earth is rotating around the sun, whatever the calendar year. Okay, so means we can say that one rotation of earth, one rotation of earth, we consider it is about a 24 hours. Okay, one rotation of means that is about the one rotation of a earth. But if you consider the calendar, In a calendar, what is it is to be considered? That is about the one revolution, one rotation of Earth at its axis. Okay, this is about a axis here. We can one rotation of Earth. This one. Okay, calendar can say that one rotation of Earth around Sun. Okay, that is about a one rotation. So that rotation, one rotation of a Earth around a Sun, that is about we can say 1 year. Okay, that is about a calendar year. In a calendar year, we can consider that one rotation of a Earth around a Sun means we can say that a solar system. If you see that there are different planets, one planet is about our Earth. Earth rotating around the Sun, it takes a 1 year, and that calendar generally we say it is about a solar calendar. That calendar is called as a solar calendar. Means what? One solar year, okay, we can say that one solar year or 1 year, we can say that is nothing but what? A time taken by a Earth, time taken by an Earth, okay, this is about a Sun and a Earth now. This is of a Earth now. Now, time taken by Earth to rotate around the Sun, it takes a one rotation, okay, or you can say that it takes one complete one revolution, okay, around it. But you can say that around the Sun, it takes a one rotation. If Earth is rotating around the Sun, it takes a what you can say a 1 year. Now then, a Earth is rotating around its axis. This Earth is rotating around its axis. That it takes a complete one revolution. This one is about a solar calendar year or solar year. We say 1 year. Okay, but a solar day. If you consider that solar day means what? A time taken by the Earth. Okay, time taken by Earth rotate. Okay, to complete one revolution around its axis. Around its axis. Now that is about we can say a time taken by the Earth to complete one revolution around its axis means one rotation around its axis. And that time, or you can say that that is nothing but a one particular solar day. And that solar day, if you consider in terms of a what you can say in terms of hours and all, that will be of a 24 hours nowadays. We can say. But how we can calculate the solar day? Generally, if you see that we need to consider at some particular instant, at some particular instant, that instant is what we can say in the afternoon, supposed to be. When your sun is located, sun appears present over it, okay, okay, it will present over it there, and then again next day again it will come at the same particular point, and how much time it takes. So that is nothing but a solar day. So then that complete solar day, and that is nothing but a solar time, or you can say that that completely particular uh, time it requires to complete one revolution means is that sun comes or sun appears again next time at that particular point. Okay, so now that particular time we consider to be a solar day, and that solar day it consists of a 24 parts, or you can say that a 24 hours. So 24 parts means what? Each part it consists of a 1 hour. Okay, each part it consists of a 1 hour, so that's why 24 hours. If supposed to be Generally, if we consider that, if supposed to be Earth is not rotating around it, okay, okay, if the Earth is not rotating around the supposed to be Sun, then what happen? So then in that case, so whatever the rotation of this particular Earth is to be taken, okay, then that is nothing but a solar day. Okay. So now we can consider that here the solar day is nothing but what? How much is the time taken by this particular Earth around itself? Then we can say that a Earth is rotating, which is supposed to be today, suppose for X day, okay, from particular day, Earth is present here. Next day, Earth will be here. Next day again, Earth will be here. So likewise, that Earth is rotating. That so it takes what every means it has some particular axis. That Earth is have some particular axis. Suppose at a day one, okay, at a day one, Earth is here. Now then another rotation, that is nothing but we can say it is about a day two. Then day three, likewise, day one, day two. Now that around this axis, it's rotate some particular angle, and that extra angle we can call it at a theta here. Okay, this angle is called as a theta. Means what? Means Earth is rotating around the sun. It takes a what? A 360 degree around the sun. But Earth is rotating around the sun, but it is progressively. Okay, it will be progressively, and it change its orbit or this change its position. So that position it changes by this particular angle of a theta here, and that angle of a theta, we can say that it is about a extra angle. We can consider that is about a theta here. Means it will take in each day. Suppose we can consider that each day it takes an angle of theta degree here in a 1 year. Okay, in 1 year this angle, okay, because it is rotating around its axis, and then this angle is nothing but it looks like a total 360 degree. Okay, so means theta, every theta, then this will be theta, then this will be twice theta, then thrice theta, likewise. So that will be of addition of a theta. Then after 1 year, that will be around a 360 degree. Means a time taken by the Earth to rotate by exactly 360 degree around its axis. Okay, around its axis is called as a sidereal day. Okay, we can say that a sidereal day is nothing but what? Time taken. Okay, time taken by the Earth, time taken by the Earth to rotate, to rotate exactly around 360 degree. Okay, time taken by the Earth to rotate exactly around a 360 degree. Okay, rotate exactly 360 degree around its exactly 360 degree around its axis. Okay, around its axis, and that is called as a saddle day. Now then, this saddle day is to be considered, or the saddle day is to be measured with particular reference point, and that reference point is at nothing but a distance star, and that is to be used to calculate the whatever the time we have. So generally the sidereal day, okay, if you consider the sidereal day, that sidereal day measured in terms of what? Sidereal day measured with reference to the sun. with reference to sun. But, or you can say that sidereal ray measured in terms of what? A mean solar time. Mean solar time. And that mean solar time, that will be equal to what? We can say that 23 hours, 56 minutes, and a 4.09 second. Okay, and a 4.09 second. Means we can say that means it takes a 3 minutes. It takes 3 minutes 55.91. Okay, 55.91 seconds to cover the cover that extra angle. What is the extra angle? That extra angle theta. Means we can say that this one is about your Earth. It rotates around it. That's for theta. Okay, thrice theta means total extra angle with respect to that distant star. Okay, so that is called as a means it takes a 3 minutes 55.91 seconds to cover that extra angle theta, and that is called as a, we can say that is about a sidereal ray and a solar time. Okay, now next we consider that a satellite orbits. What are the various satellite orbits available? Okay, we can consider here. What are the various satellites? Generally, we say that low Earth orbit. Okay, we can say that low Earth orbit. Then we can say that medium Earth orbit. Then we can say that polar orbit. Okay, that means what we can say. It is from what we can say that is about a polar there. Okay, polar system. Then we can say that a sun synchronous orbit. Then we can say that geosynchronous orbit. Okay, so now, or you can say that a geostationary orbit. Okay, this one geostationary and geosynchronous orbit. So means a period required for this. Okay, so we'll see one by one. So generally, if you see the satellite orbit, basically people have expressed in terms of what Leo, that mu, this is nothing but a Leo, this is nothing but a mu and geo. Okay, now these three, Leo, mu and geo. So for the satellite rotating around the Earth, if it is a low Earth orbit, how much time taken by the satellite to rotate around the Earth there? Now we consider first a Leo orbit. Leo orbit means what? Low Earth orbit. And that low Earth orbit, typically it will be altitude in the range of what? 400 to 1500 kilometers. Altitude means what? So now suppose we say this is about the Earth and the satellite is present here. Okay. Now this is about a satellite is present here. Now in that case, from this Earth to this satellite, that is about the altitude. From the surface of the Earth from the surface of the earth to this satellite point, and that is nothing but what we can say a altitude. Will not take here from the center of the earth. Okay, we'll take only the from the surface of the earth, that is a distance from the surface of the earth. Now a LEO orbit, or we can say that low earth orbit, so in which that height of a satellite will be in the range of what, 400 to 1500 kilometers. Okay, that is about it. Now, but if you say that this LEO orbit, old days people have used, okay, whenever that satellite as invented by the people, scientists, and they were used this LEO satellite. Why they have used a LEO satellite or a LEO orbit? Because there were a limitations of launching of a satellite. Because old days, whichever the material used for launching that liquid, that was not available to launch the satellite in the higher orbit. So there were the limitations for what? A launching. Okay. What earlier it was what? A limitations of launching. That's why the people have used that LEO orbit there. But nowadays that limitations of that launching is not available. Okay. Now, okay, right now if you see the present system, so there were no limitations of launching the satellite in low Earth orbit. So that's why so satellite can be placed in a low orbit at a various places. Okay, that particular distance. Earlier, only the people are used to send the satellite up to 400 kilometer, and then that is to be used because there were the limitations for the launching. Nowadays, no limitations. But the problem of this particular LEO satellite, that is what problem? That is a period, and what we can say that is about the height. That is rotation period. Okay, period of a satellite available in that particular region, and what will be the orbit height. That was the problem there. So we have seen earlier, okay, so that we have seen that a Kepler's law earlier, that that we can say that how much is the time taken by the satellite for a short duration, for a swift time, how much area covered by the satellite. Okay, as a swift time, we have seen earlier that we can say that is about a Earth and satellite is rotating now. Okay, so now this area covered by this in a one particular duration of a time, that we have say that swift time t1 now, that will be covered by this particular time t2, that swift time, that area a1, sorry, a1 and a2, but that time will be fixed, a1 and a2 will be same. Okay. Okay, now we see some examples of a LEO satellite. So because of that altitude is low, because that altitude is low, because of, so satellite can be launched easily, and a launching cost, you can say that the launching cost of a satellite in a low orbit is small here because of a low orbit. Launching cost reduces there. But if you use any communication there, if it is a low orbit, medium orbit, or geo orbit, so there will be atmospheric drag effect, because we'll see that what are the various perturbation occurs when satellite is used in a different orbit. So now for particular communication, so if you wanted to make a communication, So we need to use a multiple satellite, multiple satellite, or you can say that a constellation. Okay, we can say that a constellation of a satellite is needed for the communication. Why constellation of a satellite needed? Because the area coverage by this LEO orbit satellite is small. Okay, area coverage by this satellite is in small there. Now we say that a launching cost of the LEO satellite is small because it is in a low orbit. But if you use a multiple satellite, so then we need to use a multiple satellite to be launched because we need to form a constellation. Okay, we need to form a constellation. So that's why the overall cost of the system will be higher. Okay, overall cost of the system will be higher. Now means constellation means what? So is Earth, we say, suppose I am saying that that satellite is, this one is about a orbit, one orbit. So now if you need to cover the whole Earth, if you need to cover the whole the Earth, so one satellite, for example, I'm saying now this is about a satellite. So this much area will be covered by the Earth. Now for another area coverage, another satellite. For another area coverage, another satellite. Okay. Now to cover this complete Earth, so we require a multiple satellite. We require a multiple satellite. Now these are nothing but a satellite is used. These are nothing but the satellite. Now suppose for example I am saying 1, 2, 3, 4, 5, 6. Now here we say is 6 satellites required. Okay, that 6 satellite required. But that 6 satellite in a one orbit only. Now this one is the one. But we need a constellation of a satellite. Means we need to get a, because every area coverage by the satellite in a given region. So we need another orbit. Okay, likewise, we need another orbit. So now different orbit because we need to cover whole Earth. So we need a multiple satellite with a multiple orbits. Okay, so we say a multiple satellite in a multiple orbit means in a single orbit maybe a 6 satellite, in another orbit 6 satellite, another orbit. We supposed to be, we consider here if 4 orbits we are using, then 4 into 6 means we require a 24 satellite. Okay, this is the example. We require a 24 satellite to cover the Earth. So there are the different people. Okay, different uh, company they have launched satellite in space, and a Globe Star. Okay, Global Star company they have launched their 48 satellite in space there. Okay, 48 satellite in space to cover the whole Earth. Why we need to cover whole Earth? Because that a satellite is in a low orbit, is about a low orbit, means it is rotating around the Earth. Okay, so means it cover only that small portion of the area. It covers only the small portion of the area. Then throughout it is rotating. When it is rotating throughout, since it is in a low orbit, so for one rotation of this LEO satellite around this particular Earth, it will take around 90 to 100 minutes for one rotation. Means a satellite, suppose it start rotating from this place, it will take one rotation around the Earth. It takes a 90 minutes for the rotation. Means after every 90 minutes, that satellite will cover this particular area. Okay, after every 90 minutes, this satellite cover this particular area. So that's why we need to use a multiple satellite to cover the whole Earth for a particular period there. So we see one table, period, and orbits of some satellite. Okay, we'll see here the period and orbit of some satellite. Now the name of a satellite, that is the, here we can see the table here, and how much is the period required there, and what will be the height. If we say that mean orbit height, that is in a kilometer. Now International Space Center, okay, International Space Station, that it requires a, that particular satellite requires 92.83 minute, and the height is of a 415 kilometer. Now another satellite, we say RI Sat 1, okay, this RI Sat 1, it takes a 95.49 minute for the one period, and a height will be of 536 kilometer. Then a Cartosat 2B, it take a 97.44 minute, and it is about a 539. Now if you consider that geo satellite, if you consider a geo satellite, series we doesn't know, okay, will not say anything. Geosynchronous satellite. In that case, it takes what? 23 hours, 56 minutes, and a 4.1 second. All these are a minute. All these we have compared with a satellite, and then a altitude is about a 35786. Okay, that's about a altitude. So now this one is about a geosynchronous satellite, and all other are a low orbit satellite. Each and every satellite will take a 92 minutes for one rotation. One rotation, 92 minutes. And that height of the satellite is this one. And this one is a different, okay, geosynchronous satellite. So it takes a that particular time for the rotation. Now, as I told you earlier, we require a constellation. Okay, we require a constellation of a satellite for this LEO orbit. So in that case, we consider that one table here, satellite constellation system, that system providing the global mobile communication. Satellite constellation system provide global mobile communication. Now can consider that a satellite system, what are the system we have, then a number of orbits or number of satellites. Okay, then a orbit height, that orbit height in terms of what? A kilometer. Okay. Then inclination, that is I, and then the orbital period. Then orbital period. Okay. Now here the system is what? That system name is what? A globe star or global star. Okay. They have the 48 satellite, and height is of what? 1414 kilometer. Okay, 1414 kilometer. And this inclination, that is about a 50 degree, 52 degree. An orbital period is of what? 103.42 minute. And another satellite system, this one, Iridium system, launched by the Motorola, that is about a 66 satellite. And in a 66 satellite, 11 satellite in 6 orbital plane. Okay, now these are the 11 satellite. 11 satellite in 6 orbit means 11 to 6, 66. And they have the 6 in orbit. Means you can say that 6 in orbit, that is for the spare. Means what I am getting, what you are getting, they have the 11 satellite in one orbit. Okay, 11 satellite in 6 orbital plane. Okay, 6 orbital plane. So means 11 satellite in one orbit. So 11 minus 6 is what? We can say that's about a 5. 5 satellite is in use and 6 are satellite in a spare. Suppose any satellite doesn't work, or they have the problem, then another satellite will take over it. Okay, means these are the spare satellite. And your orbit height is about a 780 kilometer. And this one, we can say inclination is about 8.4. And they have the time is about the, that we can say that the orbital period is about the 100. Another system we say is of a orbcom. So in that case, they have a 29 number of satellite there. Orbital height is about 720, and inclination angle is about 455 degree, 101.827 degree. Okay, now these are about the orbcom, and these are the various systems. Now these are the various orbits. We say, for example, supposed to be iridium system. We take iridium system. So in iridium system, they have the one orbit. Okay, you can say another orbit. Likewise, you can say here now 3 orbit here, 5 orbit, 6 orbit. Likewise, they have the 6 orbit there. So means each orbit, they have the 11 satellite. Each orbit they have the 11 satellite. And out of that 11 orbit, all 11 satellite, 6 was in a spare. This one is a spare one. So now this 6 satellite is in spare. Why? Because if supposed to be any damage occur to the any satellite, in that case, then a spare satellite will be used. So this is about the iridium system. But the problem for this low Earth, low Earth orbit satellite, because that atmospheric condition, okay, because of that atmospheric condition, that low Earth orbit satellite may damage, and there what you can say, their life will be reduces. Okay, that you can say that the life of the satellite is very small. Okay, so 5 years or 10 years, max 10 years. And this low Earth orbit satellite to be useful for the remote sensing, navigation, or a military surveillance. So, or we can say that this particular uh, low Earth orbit satellite to be used for the mobile communication. Because of that, satellite is present in a low Earth orbit, which altitude is small, this orbital height is small, so we can easily communicate from the Earth station to the satellite. So suppose we say here we have the Earth station now, and here we have a satellite. We can say that we can send the signal from this Earth station to the satellite there. Because of the shorter distance of a satellite from the Earth surface, so we can send a signal to the satellite and communication can be possible easiest way because of that shorter distance. And why it is easiest? Because of the low propagation delay because of that shorter distance.